Hi everyone. In this video, we'll discuss about clipper, clamper, and peak detector. Okay. Before going to that, just we'll discuss the applications of clipper and clamper, peak detector, and all. So, what is mean by clipper? Clipper is nothing but it will clip. Whereas it will cut, right? So that is the clipper. So first we'll go with that. Application of clipper here is we can protect the signal. Okay, how here is we can keep only the needed signal, other things we can cut it off. Okay, clipper is just cutting, right, cutting the signal or cutting anything, that is clipper. Here in electronics, clipper represents clipping the signal. Okay, next one is signal conditioning. We can condition the given signal by using clipper. The main application of clipper is waveform shaping. We can shape the waveform by giving the reference voltage. Particular depends on the reference voltage. We can shape the waveform here. We'll discuss in the next slide. Next one is voltage level shifting. Okay, we can also shift the voltage level, and in protection also, that is in electrical protection also, clipper is used for over voltage protection. Over voltage protection, when there is over voltage, we can cut the supply, right? So it is also used. Next one is noise suppression. We can suppress the noise when it goes beyond the limit or beyond the voltage. Okay, next one is clamping signals, audio signal limiting, voltage regulations. These are the applications of clipper. Okay, now we'll see what is the clipper. Okay, I've explained previously, right? A clipper is a circuit which is used to cut off the desired shape, depends on the shape. A diode may be used to clip off a certain portion of input to obtain a desired waveform. Okay, here we are using a diode in order to clip the voltage, right? For example, how the diode works: in forward bias it will conduct, in reverse bias it does not conduct. Basic, right? So if it is forward, if the diode is in forward condition, your waveform will be there. If it is reverse, your waveform will not be there. Simple, right? And here we are adding an extra with we are making with the reference voltage. Okay, and why we are using op-amp? The basic clipper is constructed by using a diode, a simple diode, right? And here we are construct using a operational amplifier. When you are using a simple diode, you'll not get the proper clipped waveform, because there is a diode which will be connected in parallel to the output. Because of the diode potential, okay, which is inbuilt potential, your waveform will not be clear or will not be specific. Okay, that is the reason we are moving for the operational amplifier. Okay, so the portion of output waveform where input voltage is, when the input voltage is greater than V reference, your waveform will get clipped off. Okay, it can cut. Okay, so you can just refer this voltage. This positive clipper, a positive clipper with V reference positive and V reference negative. When the V reference is positive, our positive waveforms get clipped. Okay, this condition in positive clipper with negative reference voltage, a positive waveforms get clipped. So positive clipper, it clips the positive cycle of the waveform. You can just remember like that. Okay, a positive cycle of the waveform. Okay, then your output will be like this. Next one is negative clipper. What is a negative clipper? As positive clipper, it clips the positive waveform. Negative clipper clips the negative part of the waveform. Okay, for example, we have two constraints. Same goes with positive V reference and with negative V reference. So when there is a negative reference voltage, our negative part of the waveform gets clipped off, right? And when there is a positive V reference, also a negative part of the waveform gets clipped off. So keep this in your mind. Negative clipper clips the negative values. Clamper. So the application of clamper, normally what is mean by clamper is it's like giving a DC voltage. Okay. So the applications are audio signal clamping, video signal clamping, DC restoration, data transmission, biasing in amplifiers, PWM, zero crossing detectors, and power electronics. Listen, the main thing is we can just we can make the value to 0 or any other specific values, because we can move the AC waveforms by applying a specific DC value. So that what happens, the waveform gets shifted. Okay, for example, if the waveform is in 0, we are giving 2 voltage, DC 2 voltage, our voltage gets clipped off. I mean, it just clamp to the, we are giving positive, it just moves upward. So we can move the waveforms, okay? And if it is not in orderly position, that time also you can make it to 0, standard positions, okay? Here, see, the clamper, it is used to add a desired DC level to the output voltage. You can add desired DC voltage here, okay? You can just see the output voltage. Your input is like this, but see the output, it is not in the position of 0. It gets shifted because of the DC voltage we have given here. Next one is peak detector. From the name, you can just easily identify what is peak detector. We can detect the maximum voltage. So that is the work of peak detector. So you can just refer the graph. You can easily understand. For example, first initially we are giving off some voltage. For example, it can be, okay, you can just take it as 5, okay? You can take this as 5. This is the starting value, so it gets stored. Next, when it increases to 8, it stores the value of 8, okay, over 5, okay? It will only store the highest maximum peak values. So when it goes 10, what happens? This 8 is replaced to 10. If it decreases, there is no problem. It will not store. It will only hold the highest value. So that is the work of peak detector. Okay. Next one is just go through this question. Which circuit boosts the voltage? Can go through this clipper, clamper, and peak detector. Whether these three will boost the voltage? Not right. Yes, it will not boost the voltage. For boosting the voltage, we can go for amplifiers and all. That's all with this video. Thank you.